Yes, ma'am, please start now.
A very good afternoon to one and all. So we are starting the day 7 of our FDP on machine learning fundamentals, and we have our honorable guest, Dr. Pooja, here with us today. We welcome you, ma'am. Before I request you to take over the session, I would like to introduce Dr. Pooja to our audience. Dr. Pooja is an accomplished individual with almost 2 decades of experience in imparting education and making significant contributions in the field of computer science and engineering. With a strong background in education, she has dedicated her career to sharing knowledge and inspiring others through her expertise. She has delivered numerous hands-on training sessions to students, learners, industry personnel on artificial intelligence and machine learning using Python. Furthermore, she has worked with NITTTR Chandigarh towards co-creation and delivery of courses for National Online Education Portal, that is SWAYAM, NPTEL, on smart grid analytics implementing machine learning module. Throughout her professional journey, she has published over 90 publications, which include national and international journals, conference papers, book chapters, including IEEE, Springer conferences, and Scopus Index journals. The extensive body of work reflects her commitments to advancing knowledge and making valuable contributions to the field of artificial intelligence and machine learning and deep learning. Her expertise and insights have likely been sought after by peers, students, and fellow researchers alike, and we are very fortunate to have her with us here today. Ma'am, the audience would love to hear from you, so handing over the session to you. We welcome you once again.
Am I audible?
Yes, ma'am.
Thank you so much for this introduction. I think we shall start the session, right?
Yes, ma'am.
Shall I start presenting?
Sure, ma'am.
How can I start sharing? Just share? Yeah, just share. Is my screen visible? Yes?
Yes, ma'am, it's visible, but if you can do it on full screen.
I will do that. I will do it. I'll stop my video. All right. So, is it visible now? Full screen?
Yes, ma'am.
All right.
It's okay.
Thank you so much for inviting me on this 2 weeks faculty development program on MATLAB. I would like to thank, I don't know much of the people from other collaborations, but I definitely know Dr. Meherchand. Thank you so much for inviting me, sir. And many congratulations to all the collaborators and organizers of this FDP for conducting it on this bigger scale. So today is day 7, and the topic which I will be talking about is on machine learning fundamentals. So considering, so I have prepared this session for beginners as well as intermediate learners. So we'll talk about machine learning, what it is, what is supervised and unsupervised learning. Then we'll jump into the machine learning process. We'll see what are the data preparations and how data is prepared, what is feature extraction, small parts. We'll talk about training, evaluation, and models. And then we'll, at the end, we'll build and evaluate a machine learning model in MATLAB using onlinemathworks.com, right? So we'll start with introduction. Machine learning. Before I start, let me ask audience, what do you know about machine learning? It is a buzz these days and people know about what machine learning is. So I would like to understand from participants, what do they think about machine learning? Anybody can speak. if it is so. Otherwise, I'll start going through the slides. Anyone? Just to have an understanding where we all stand. Just wanted that so that I can mold my session to that level. All right. So I will start then. So machine learning is actually a subset of artificial intelligence. If you will see, there are typically two words, machine and learning. So what we do, we try to make our machines learn something. Now that learning is actually, we are trying to put intelligence into a machine, and that intelligence is not the actual, that intelligence is not the actual intelligence, but it is artificially generated intelligence. So that is why it is a subset of artificial intelligence. So when we say artificial intelligence, we understand that human species is the most intelligent form in this universe, and from other species also we try to understand how they do their tasks, their daily tasks, how they behave, and then we try to mimic that behavior into machines, right? So there are steps. The way we start learning, typically based upon same things, we try to make our machines learn using different algorithms, right? So what is the primary goal of machine learning? The primary goal is to enable computers, not just computers, it could be any machine, right? So when we say computer, computer typically means a laptop or a standalone desktop. No, anything which can have a processor, which can have a memory, can learn things, right? So primary goal of machine learning is to make the machine understand the patterns and make decisions, predict something without without we program that machine rule by rule or step by step. So we need not to write a typical program, if these do that, if these do that. So by doing that, we are giving explicit instructions to the machine, and beyond that instructions, machines will not be able to do anything, right? That was the traditional approach of learning. But in machine learning, what we do is we make machine learn the data itself. So when we say machine is learning the data, machine is actually trying to understand the pattern in between, and then based upon that pattern, machine is now capable of making decisions for unseen inputs, right? This is what is the goal of machine learning. So there are typically, if we say traditionally, there are two types of machine learning, supervised, unsupervised learning. But if you will see the current scenario, there is a lot of research has been made. So there is semi-supervised learning also. Reinforcement learning was already there. Supervised learning is also there. So these kind of learnings can be done on a machine. So we'll see what is supervised learning first. So in supervised learning, what we do, machines learn from a labeled data. When we say labeled data, labeled means there is data, the features of the data, the attributes of the data, and for every single observation, there is a target or the output of that particular data. For instance, how can I include white background? I don't know. So for instance, let's suppose we have a data of height of a student and corresponding weight of the student, right? And there is there is another feature called hemoglobin, right? So let's suppose first observation or record in this data is height is 5 feet 7 inches, let's suppose. Weight is 70 kgs, human globin is 8, right? So when we are seeing this, the output may be the person is healthy or unhealthy or anemic. So based upon these parameters, what is the height, what is the weight, what is the hemoglobin, whether the person is male, female. Based upon that observation, there is an output, there is a label attached to that observation, that the person or the patient or the observation being considered is a unhealthy or healthy person. So this is what the label is, right? So what in supervised learning is done, we train the machine considering input and output pairs for making predictions. Next is unsupervised learning. In unsupervised learning, see, in supervised learning, what was happening? There was some label to check, to identify whether the learning is being done correctly or not by the machine. In unsupervised learning, there is no labeled data. There will be data only. There will be only the features, no outcome. So what algorithm does? Algorithm identifies the patterns or structures within the data and try to accumulate data points into groups. Typically, it results into clustering kind of learning. In semi-supervised learning, as the name suggests, we have a combination of supervised learning and unsupervised learning. Now, what does this mean? This means we do not have enough labeled data to make our machine learn. So what we do, we take that labeled data, small amount of labeled data, and then there is unlabeled data. Then based upon that labeled data, we predict the labels for unlabeled data first, and then we create a fresh data for making learning. So it is a combination of both supervised and unsupervised learning. This is what semi-supervised learning is. Reinforcement learning is when the machine is learning in the actual environment. So there is a direct interaction with the environment. For instance, you and I right now in an environment where you are, let's suppose you are the environment and I am the machine. So what I am perceiving, I will perceive your voice or commands, or I will read the chat, and accordingly, based upon your commands, I will change my methodology of teaching. Right? So what is happening, if your comment in the chat or your voice command comes as a poor learning experience for you, or it is a bad comment, I will try to improvise my teaching right now. Right? So this is how reinforcement learning happens. It happens through the interaction within the environment. Algorithm or the machine receives the feedback from the environment itself, whether what machine is learning or what machine is doing or taking action is a good one or bad one. So based upon that feedback, machine is given rewards or penalized. And based upon that reward or penalized, the machine learns. So if machine is penalized, machine will learn that the action taken based upon the inputs from the environment was wrong. Machine should change the action. This is what it is. This is just a very brief introduction to what different types of machine learning is. If you will have any questions, you can just ask or drop a message in the chat. Now we'll try to go in depth of each of the learning. So we'll talk about supervised learning. If you will see this image, by the way, this image was generated using generative AI. So in this image, if you will see, there is a teacher and there is a student. So usually how do we learn? We learn like this, right? So you are learning something, and when you are asked whether it is a 1 plus 1 is 2, whether 1 plus 1 is 2 or not, and you are saying 1 plus 1 is 1. So teacher is there to correct you that 1 plus 1 is 2, right? So in supervised learning machine learning algorithm, the machine is taught by examples. Now that example is the observations from the data itself, right? Now what happens? There is data with input and output. Input and output means like input was 1 plus 1, output was 2. So if machine is learning 1 plus 1 is 0, the feedback will come that it is incorrect and machine will change its inner mathematical model, right? This is how machine learns. So this is what supervised learning is. So what happens is the algorithm identifies the pattern in the data, learns from the observations and makes prediction or classification. So when we say supervised learning is basically, we say it is classification or regression. So when we do classification and when we do regression, we'll talk about that also. So in classification tasks, what exactly happens? Your labeled data, the label in that is typically a categorical data or discrete data, right? When your labeled data is categorical, for example, categorical means healthy, unhealthy, male, female, yes, no, spam, not spam, this kind of, maybe not 2 categories, maybe many categories, healthy, unhealthy, anemic, something like that, right? So whenever your data is categorical or discrete in number, discrete means, let's suppose category 1, 2, 3, category 5, 6, 7, right? When your label in the labeled data is like this, we perform classification. So classification means the whole data can be classified into those categories as mentioned in the label. This is what classification task is. A very common and well-known example is filtering of emails as spam or not spam, right? Next is regression task. Now in regression also, it is supervised learning. There is data with the label, but now the label is a continuous data. Continuous means there is no particular category. There is no 1, 2, 3, repeated 1, 2, 3, 1, 2, 3. No, it is continuous in nature. For every other observation, the label is different. For instance, the price of a house, the price of car, based upon the features of the car, what is the price? So price of house or price of car can be in floats, right? Can be 2 lakh, 2.5 lakh, 4 lakh, 5 lakh, 6 lakh, something like that. So it is continuously. If you will see the only label of the data, that particular attribute, you will see that it is continuous in nature. When the data is continuous in nature, then we perform regression on the data, and in regression, machine learning algorithm will understand the pattern, and based upon the label, it will try to predict or forecast the value for an unknown data point, right? So usually there is, in regression, there is dependent or and independent variables. We say it like this. Hope you are understanding. If you, I'm sure you must have came across different data sets. If not, I can show you some of the data sets so that we have a better understanding what is categorical and all that. You just have to drop me a message. All right. Next is unsupervised learning. Now in unsupervised, have we done this? Yeah. So in unsupervised learning, what do we have? See, there is nothing to teach you or teach the machine what is what. Whether this is red, this is orange, or this should be one category, or this should be another group of data. No, there is nothing, no label, right? So what do we have? We have data set without any prior knowledge of the target value. There is no output, no label. So how does machine learn? Machine tries to understand the pattern between each data points. So how will a machine understand the data points? It will try to understand the relationship between one data point and other data point. Maybe it will try to understand or formulate or calculate the correlation. Maybe it will try to understand the distance between two data points, how far or how near two data points are. Now, based upon that, what does it do? It group different data points together, right? So if the distance is less, for instance, if I will say, if I have to classify whole this image into two categories, so what will be the two categories? We'll pick one data point, this, it is red. Next data point, red. They are both near to each other, clubbed together, one cluster. Second data point, let's suppose this is yellow. Yellow is near orange, orange is near red. So clubbed together. This is how it is all mathematical. So when we say machine learning algorithm means a mathematical model, nothing else, right? So this is how, based upon some distance matrix, it will try to understand where two data points lie, and it will try to combine or make them, club them together to make clusters. In supervised learning, unsupervised learning, either clustering can happen, dimensional reduction can also happen. So unsupervised learning algorithms are also used to reduce the dimensions of the data. So usually data is huge. That is there is a term in machine learning and AI which is known as curse of dimensionality. So as the data grows, the performance, I mean, it takes more time to learn, right? So somewhere we have to strike a balance between what will be the data, whole data set size. So sometimes if we have to consider whole data, we reduce the dimensions, we try to change the data into some other, we try to transform it into some other form. Not going into the depth of that. So clustering means grouping similar data based upon defined criteria. Now that defined criteria usually is distance, and very commonly used distance in machine learning is Euclidean distance. In dimension reduction, what we do, we try to reduce the number of variables, right? Usually it is done by transforming data. So maybe 4-dimensional data is there, it will be transformed into 3-dimensional. 3-dimensional data can be reduced by transforming into 2-dimensional data. So this is how dimension reduction happens. This image I have taken from mathworks.com. Mathworks is an organization. You understand MATLAB, right? So this is the organization who's behind the development of MATLAB. So MATLAB is owned by MathWorks, right? So according to this particular page, machine learning can be unsupervised, supervised, and in unsupervised we can have clustering, in supervised we can have classification and regression. Again, this is taken from MathWorks only. We'll talk about reinforcement also. So in unsupervised learning, we do not define what it is. We will try to group the data together. See, the same data points are grouped together into 3 different clusters, 3 different colors. Supervised learning, there will be a defined border line between 2 groups, 2 categories. So category of blue circles, category of green plus. In reinforcement, as I've told earlier, what happens is, based upon the learning in the environment, the reward is changing. Reward is 0 when machine is moving from this to this. Reward is, this is data point, reward is +2 when machine is predicting it as this. So this way it learns. Now, reinforcement learning is something like this. You're training your dog, right? We'll say this is not a dog, this is a machine learning agent. Okay. In artificial intelligence, we typically say agents. We develop agents. We write agent programs, right? So agents interact with the environment. So how do they, in reinforcement learning, what is happening? Let's suppose you are the trainer, you are the environment, you have thrown the stick. If the dog takes action and picks up the stick, you give the reward. And based upon the reward, now the dog is feeling elated, happy, and then it learns. So every time the stick is thrown, the dog has to pick it. So this is how from the environment agent learns, right? So in machine learning, there can be in under these categories, classification, regression, clustering, there could be many algorithms, right? So these are the list of algorithms. If you want, we can go into depth of any one algorithm. Otherwise, I have shared the references also to learn these algorithms one by one, right? I'm skipping all this because I want you to, I want all of you to do a hands-on session with me, along with me online. So I'm just taking you there. This is a small video. It is taken from Simply Learn. It is available on YouTube. In this video, you will see how these three types of learnings, reinforcement, supervised, unsupervised, are different from each other. Let me know if you are able to hear it. Are you able to hear it? Yes? No? Yes. Okay. All right. Let's watch it.
Hello
What has
everyone.
happened?
Welcome to this tutorial by Simply Learn. In this video, you will learn about an interesting machine learning topic, that is supervised versus unsupervised versus reinforcement learning. Let's discuss each of them in detail and understand when to use in the field of machine learning to solve complex problems.
We'll see this.
Let's look at the definition of each of these learning techniques.
So we have seen
Supervised learning uses labeled data to train machine learning models. Labeled data means that the output is already known to you. The model just needs to map the inputs to the outputs. An example of supervised learning can be to train a machine that identifies the image of an animal. Below you can see it's a bus or a truck. So the model learns by identifying the parts of a vehicle, such as the length and width of the vehicle, the front and rear end covers, roof hoods, the types of wheels used, etc. Based on these features, the model classifies if the vehicle is a bus or a truck. Reinforcement learning trains a machine to take suitable actions and maximize reward in a particular situation. It uses an agent and an environment to produce actions and rewards. The agent has a start and an end state, but there might be different paths for reaching the end state, like a maze. In this learning technique, there is no predefined target variable. An example of reinforcement learning is to train a machine that can identify the shape of an object given a list of different objects such as square, triangle, rectangle, or a circle. In the example shown, the model tries to predict the shape of the object, which is a square here. Now, let's look at the different.
So I will stop this video here. When I share this presentation with you, you will have an access to this video, right? We'll just move ahead with the key components of machine learning. So what do you need for making your machine learn? Very important thing is data. The better the quality of data, the better the learning will be. If your data is labeled wrongly, the machine will learn that as it is. Let's suppose you have images of dog, but those images of dogs are labeled as cats. So every time your machine will predict a photograph of dog, it will predict it as a, or it will classify it as a cat only. So data here is very important. So that is why it is said, it is done actually, that most of the time is spent on making the data quality wise a good and better data, right? So this is very important. So what do we do with the data? Whenever we get raw data, we try to do something on that data, which is known as data pre-processing, before making that data as an input to the machine learning algorithm. We pre-process the data, right? Next is algorithm. We have seen a lot of algorithms. So in machine learning, algorithm is what? It is a mathematical model which will process your data and extract some meaningful pattern or relationship in the within the data points, and according to that it will try to predict the, or it will try to classify the unseen data pattern, right, when you will implement it. So what do we do while learning? You need to evaluate it. You need evaluation of your algorithm, whether the algorithm has learned properly or not. So there can be a lot of evaluation matrices. There are a lot of evaluation matrices which are used to verify whether the learning has done correctly or not. Then there is a loop. We'll see it in the next slide. Then there is a loop. So after evaluation, if the feedback, if the evaluation says the accuracy is 60%, we go back to our algorithm. We try to modify it. We can go back to our data. We can do some feature engineering, identify best features out of the data so that our model can learn better. So this iteration goes on until we get the better evaluation results. Once you are satisfied with the evaluation, you go for implementation. This is what is the machine learning process is. So major components are data, algorithm, evaluation, and implementation. So data collection is the first thing. So when you collect data based upon your requirement, right? So for instance, if I intend to create a machine which will identify whether a person or a patient has diabetes or not, I will have to collect data of the patients from the hospitals, and the important features of the data should include the level of sugar, hemoglobin, weight, all those things which are actually required to identify whether person will have this disease, diabetes or not. So gathering relevant data is very important. First, you have to gather the data based upon your requirement. The data should have those features, right? Second, you have to now pre-process the data. So the next step in machine learning is pre-processing of the data. So what do we do in this pre-processing? We usually clean the data. So there, when let's suppose we'll take very relevant, very, I mean, you all will understand this example. For this workshop, every day feedback form is being sent, right? So mostly this is one way of collecting the data, Google form, right? Or a survey form. So what do we intend to do? We intend to understand whether the training or whether this FDP is going well or not. There might be some questions, right? Relevant questions. And based upon those data, we will try to do what? We will try to rate the trainers, right? Whether the trainers were good or not, whether they fulfilled the requirement of the FDP or not, right? Now what happens when we float this kind of survey, or when we try to collect data, maybe due to some technical reason, or maybe user does not want to give whole information, so some of the fields might be kept vacant, or they will be values which will be missing. Or while typing, let's suppose you were typing a feedback, the session was excellent. Instead of excellent, you wrote something else. So there was a spelling mistake. So when that data will come to us and we try to create a model, we will try to extract excellent out of that. But your observation which you have filled in will be missed because the spelling of excellent are different, right? So this is just one example why we need to do data pre-processing. We need to understand whether the data is good or not. We need to clean it, we need to transform it. We might have to prepare data for analysis using different features also. So maybe not all the features are relevant for our task, right? So what we will do, we will extract the important features out of the data, and the rest of the data we will not use. There might be a data which must be carrying similar kind of data, similar kind of features, right? So maybe we can combine two features together. So all these things happen in data pre-processing. Oh, I have changed the screen, right? So sorry. Okay. So next is model selection. Once you have the data ready for your analysis, now you need to understand which machine learning algorithm will be appropriate for your data. As I mentioned earlier, based upon data, if your data is labeled, you should go for supervised learning. If your data is unlabeled, you should go for unsupervised learning, right? So you need to understand which type of learning is to be implemented. Then within that type, which algorithm will work better. Now this choice can be made, or it will be made easily for you when you will have more experience, when you are more into this practicing machine learning algorithms. Otherwise, what we do for beginners, we tell our researchers also, or the persons who are using, we tell our data analysts or machine learning engineers to do what? To implement all possible machine learning algorithms on the data, compare them, check which algorithm is better suited for this particular data. And it is not about the best. Maybe your model is giving 100% accuracy, but in actual scenario, it won't give that. So there is another term in machine learning, generalization. There are a lot of concepts we have to keep in mind while while finalizing your model, right, for your application or for your machine to learn, right? This is one thing. So once you have selected the model, you train that model on the data. So usually training is done not on the whole data. You pick some part of the data, then on the remaining data, you test your model. When you test, then you evaluate it. You verify the performance based upon some evaluation metrics. We will talk about evaluation matrices also. And then at the end, once you are satisfied with all, you deploy your model for real world use, right? All right. Now we'll talk about data pre-processing. Now, what is data pre-processing? Data pre-processing involves cleaning, organizing raw data. And why do we do that? So that it is suitable for your model to be used, right? What does data pre-processing ensures? It ensures data quality. It enhances model performance and reduces training time. If you will start preparing your model on the raw data, it might take a lot of time to train it, or it might not give you better results, right? Now, what are the key steps in data pre-processing? You clean the data, you transform the data, you split the data, you do feature engineering on that. We'll go to this site. Oh, I have not I want you to see this. Give me a second. Oh, annotation was there. I want you to see this. This is a very good reference from KG Nagars. I want you to see, there was one image here, this. These are the actual these are no, what is happening here? These are the actual steps you do in data reprocessing. You clean it, you do normalization, you transform it, you find missing values or you remove them, you integrate data, you identify noise, try to remove them. So these are some of the steps which you do. This link is there in the presentation, and I would recommend you people to read this also. Let me put this link also. All right. So what is data cleaning? In data cleaning, we try to detect and correct or inaccurate records from the data. As I mentioned earlier, there might be some spelling mistakes. There might be, let's suppose the price of house was supposed to be written as 60 lakh, but it was written 6,000 lakh, which would be incorrect. So for verifying that accuracy of the records inside the data set, what do you need? You cannot just guess it as a data analyst or machine learning engineer. What you need to do is, the correct way would be to talk to the expertise of the domain. So if your data is related to healthcare, talk to the person who is taking care of that healthcare department, right? Or there must be somebody in your team who is a domain expert actually, right? So if your data is from let's suppose sales and marketing, check that domain expert, and then you will be able to understand whether that record is incorrect or correct, right? You cannot just do it on your own. Oh, this seems incorrect, let's change it. No, if you will do that, you are adding bias into the data, right? So we don't want to do that, right? So it is not data analyst's job to do it, right? Actually, so you need domain expert, you will verify it, and then you will correct it if required. So typical operations you perform in data cleaning is, you handle missing values. Either you remove the missing values or you impute new values in the places where the values are missing. So imputation can be done using mean of whole attribute, median of attribute, mode of attribute, or what suits better based upon after consulting the domain expert, right? There might be duplicate values, so you have to remove duplicates. You need to address outliers. Now, what are outliers? There is annotation here, right? Let me take it. I'm on the whole screen, right? I should be here only. Yeah, now I will use annotation. No, it's not working like this. Yeah. So annotation, let's suppose we have data of age, right? And the data points are 20. It is very bad. There is text. Let's suppose the data point is 20. 19, 22, 23, 18. These are the persons in the who are attending, let's suppose this particular FTP, their age, right? 25. And then this is the data. Now what will be the mean? The mean of this data might be near 22, right? Now let's suppose now in this data, maybe wrongly or mistakenly, or there was one participant whose age is 70. Now what has happened? Altogether, the mean of this data has changed, right? And when I'm saying machine learning algorithms are mathematical model, this will now affect the overall learning of your machine. So this 70 now is what? This 70 is an outlier. So what we need to do, we need to understand what is the effect of this outlier, whether we can remove this outlier or is it important data point. If it seems it is not an important data point and it is just an outlier, we can remove these outliers or we can address it using different methods. Some of the methods are mentioned here: Z-score method, IQR method. There are different methods to deal with outliers also, right? I need to erase it. I've forgotten how to use it. All right. This is what is data cleaning. In MATLAB, to clean the data, these are some of the commands. RM means remove, missing means missing values from where data. Okay, you can check for the duplicates and remove them using unique on your data. But before that, data should be loaded on the machine. We'll load and we'll do all these things, right? So next is data transformation. Now data transformation means you need to change the data into a suitable form or format for analysis. So what we do, let's suppose we had data. The data was age, and then there was height of a person. Now age says there are two data points, 20, 24, 23, 19. 9 data points for age. For height, for these people, let me do it differently. 20, 21, 19, 23, 22. This is age. Now corresponding height of the person is 5.5, 5.7, 6, 6.1, 5. Now see the range of this and the range of these two attributes. Age is lying between range 19 to 23, while height is between 5.3 to 6.1. So when we will try to when machine will try to learn the pattern, the range is far apart from each other. So usually what we do, we scale down all the features into one specific range. We usually do it by using methods known as standardization or normalization. Normalization means everything is mapped between 0 and 1. So when we will normalize age between 0 and 1, 19 might become 0 and 23 might become 1, and all other values will be mapped accordingly in between the values 0 and 1. Got it? So this is one way of transforming your data. Next, your data might be in categorical form. Let's suppose male, female, gender. Now the gender is male, M for male, male. So Oh, sorry, let me take this female, male, 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 and female. Now see, this attribute is categorical. Now, when machine learning means mathematical model, computer will understand only numbers. So computer cannot understand what is F, what is M. So what we need to do? We need to encode these categorical values into numbers. So maybe my female can be converted into 0, males can be 1. So there are some methods like one-hot encoding, label encoding. There are a lot of methods actually. For these are just few methods mentioned for encoding categorical values into corresponding discrete values. Okay. Now you can also do feature engineering. Now what does feature engineering means? Feature engineering means maybe there are features. Let's suppose height and width of the room. So now you don't want two features. What I can do? I can combine those two features and create new feature called area. Right? So something like that. So what we try to do? We try to create new features from existing data. Not just new features. You can eliminate a feature which is not serving much of the purpose also. Okay. This is what is data transformation. Now in machine learning with MATLAB, these are some of the commands. So simple normalize on the data, you can normalize the data. Then for one-hot encoding, you can use dummy variable function, and then you can extract from this data the categorical variable like that. You go into that feature actually, and then you put dummy var function on that, right? Next is data splitting. I need to finish it up quite soon. Okay. Data splitting means now you want to train your model. Your data has been cleaned. Now data is ready. Now you need to train your model, right? For training your model, you usually split your data into training and test sets. Or you can also use validation set to check whether the results are valid or not. So training set will be used to train the model. Test set will be used to evaluate the model's performance based upon some evaluation matrix. So in MATLAB, there is a function CV partition. CV partition will help you partition that data into training and testing. This 0.3 means 30% of the data will be used for testing, 70% data will be divided into kept for training purpose, right? Feature extraction. Now feature extraction means you transform raw data into features that better represent the data for predicting model. So usually feature extraction is done for reducing dimensions or enhancing the performance of the model. There are some methods or algorithms which you can use for dimensionality reduction, like PCA, principal component analysis, very commonly used. Singular value decomposition, SVDs are used. There are other feature selection methods also. So you have 10 features in your data, you want to select best out of that. So there are some methods. So for example, correlation, you filter this is known as a filtering method. Then there is a wrapper method like stepwise regression, or there is embedded method like lasso, regularization and all that, right? So we are not going into depth of all these. Okay, I will open this for matrix and all, and then I will let you know. I want you to create your login. You can just go through this, what evaluations matrices can be used. I'm not going all, showing you all. These are, let me open this. Is my screen visible, right? Yes, it is visible. Okay. So for regression, usually these matrices are used. For classification, we check for accuracy, precision, recall, F1 score. There are set formulas. You need not to even learn the formulas, but you should know if you are using MATLAB or some other platform, you should know what are the commands and how does these work, right? So usually in regression, we use error matrices like R square error, root mean square error, mean square error, mean absolute error. We try to understand the difference between predicted values and the actual values of the. This is what we do in regression. In classification, we do accuracy, whether the classification was done accurately or not. We can also use confusion matrix, right? Confusion matrix is a matrix which is very commonly used to understand whether the classification is done accurately or not, or how many true positives were there, how many true negatives were there in the data. Now what I want you to do is not this. I want you to create login into this MathWorks. I will share this link with you. This is an online chat. Z-score is based upon Paramjit Singh. Z-score, what we do, we based upon standard deviation, second level, first level, third level standard deviation. We remove that standard deviation from the data. And then we produce the Z-score. Okay. I want you all to create your login here right now. And then we will do this hands-on session on MATLAB. There is on MathWorks, there are some freely available courses to practice MATLAB for machine learning. We will pick this course. Are you with me? So open this, create your login, and then go to Academia. Let me do it here. So create your account on MathWorks. Go to Academia. Step 2. Go to Academia. I'm just writing so that you can do this right now. Step 1 is create your account. Step 2 is go to Academia tab. Step 3 is click on learn. And then go to online training. Under Academia, click on learn tab. Then step 4, click on online training. Okay, so once you will do this, you will come to your so many courses here, and most of the courses are available on online MATLAB portal. Okay, so today you can do MATLAB on ramping. It will help you understand all MATLAB, and at the end you can get a certificate also. But for today, we will do machine learning on ramp. Okay, we will open this. Then step 5, start course this. Okay, link is already there. So once you will open this course, I will show you. You will, here it will happen, it will be start course, right? So we will start this course. I'm resuming. I want you to see the course, whole course. We'll skip this. Here is the course. It will start with an overview of machine learning, small video. You can just see this. We'll start from importing data. Okay. How to import data into MATLAB if you have some data set. So in this particular course, there will be handwritten data. Are you all with me? Shall we start? We'll do the till classification. Are you all with me? Anyone? Yes. Okay. Once you are ready, just give me a yes so that we can start. I'll give you 5 minutes are enough to create the account and open this. Shall I share the steps? So steps are here. Do this. Are the steps visible? Okay. Natraj, I'm waiting. Once it is done, one of you has to tell me, okay, we can start. Where is my screen sharing? Okay. So on the screen are the steps. You have to go to this website, create your account on MathWork, then go to Academia tab. Once you are logged in, go to Academia tab, then under Academia, click on Learn tab, then click on Online Training, and we'll start with Machine Learning on RAM course. And for practicing MATLAB, you don't need the downloaded version of MATLAB. You can practice here. And you can do these certifications also. Some of them are totally free. Once you're ready, please let me know so that we can start. Okay, we can start. All right, Rohit. We are starting. So I am going to All right. This we are done here. So as you can see, okay. All right, if registration is over, let's start then. Is my screen visible? No. Okay, is my screen visible now? Yes, right? So I'm skipping the first video. I'll start with this. We'll learn how to upload the file and then how to do some of the things. So see, there is this data. The data set is about, the data is in the text form and it is handwritten, small handwritten letters in that. Okay. Now, in this text file, what is mentioned, if you will see here, each file is comma delimited and contain 4 columns. Okay, so every text file, there are text file for J, M, and B handwritten letters. There are 4 columns. So data is in the 4 columns. One is time, then the horizontal location of the pen, then the vertical location of the pen, and the pressure of the pen when the person was writing. So if you will see here, there are 4 columns: time, X, Y, and P for pressure. So the data looks like this. Okay. Now, what is our task? So this is what? This is the live editor of MATLAB. It is similar to if you will download MATLAB and start using it. It is similar. So MATLAB looks like this. There will be an editor. Okay. So what we will do now, first is we need to import the data. And if you will see here, the background and everything is mentioned. So one by one, you will start picking the task and you will complete the task, right? So it is saying to read the table, you need read table function and the file name. Okay. So what is the task? Task is read the data stored in j.txt and save it into the name letter. This is our task one. This is my task one. Let's do it. So the variable name is letter. Now letter is equal to, what is the function to read the table? Read table. And what is my file name? File name will be in commas. So what is my file name? j.txt. Done? Okay. Now what I need to do? I need to execute this command. You can run it from here. Okay. You can run it from here. You can use control enter command also. So this task has been executed. And if you will see here, this is the variable, what all variables we have. Okay. So I have variable letter. The size of this table is 27 by 4. Okay. See, this is my first file. Understood? You can open it here also to view the variable. It will get opened. This is what my text file has been imported into MATLAB, and now it looks like this. Understood? All have done? If yes, please mention. Yes? Okay. Yes. Done? So what we have done? Now we have imported a tabular data. How to import a tabular data in MATLAB? Read table function. Simple. All right. Let's move to, now once you are done with the task, let's submit it so that we can start doing our this also. This certificate also you will get. So today's task will be you complete this machine learning on ramp. Okay, so for tomorrow's session, we'll do deep learning. Okay. Okay, Nakum, thank you so much. All right. So my first task is done and it is correct, right? Now let's move to next task. Now what is it is saying? It is saying in machine learning, in this MATLAB, you can use dot notation to refer to the individual variable within the table. So if you want to know what is X, what is Y variable, what is time variable, we can use dot notation. Okay. Next task is this, right? So for example, I will just do it here for you. Let's suppose letter is my table, letter dot X. If I will do this, I will get X only. This is not the task, but I'm just showing you. All the values of X are here. Okay. But what is the task? Task is saying visualize the letter by plotting X variable of letter on the horizontal axis and Y variable on the vertical axis. Now what do we need? We need to visualize it. To visualize it, we need plot function. There is another course which is MATLAB on ramping. Do that also. And what we need to do? See, plot. What do we need to plot? We need to plot X versus letter dot Y. See if it is working. See. It is variable X on the horizontal. Have it. This is what my image is. Let me change it a bit. Let me submit. I think it is correct. So see how does my J works? My J works. So for this particular J.txt, when we have plotted X is to Y, this is what handwritten J looks like. Done with this? So what was the function used? The function uses plot. What do you want to plot at X? You will mention that here. What do you want to mention at Y? You will mention it here. Done? Yes, no? Okay. Yes. Let's move to next. Now what do we need? If you will see, if we will open this again, see. Now this is x-axis starting from 0.375, 0.41. And y is starting from 0.18 to 0.36, right? So what we will do? We will equalize the aspect ratio of x and y. Okay, then you will see it differently. So how we will use? We will use access equal command. You can see the hint here if you do not know. So what we will add? We will add let me see the solution. I've forgotten. Here is the solution. Simple access equal at the end. Okay. Not within this. So this is my task list. Plot has been done. On that plot, when I will use access equal, it will equalize the access. Now we will see what has happened. Now see. Now it is looking like a proper J. See? Got it? This is handwritten J. All right. We have submit task 3 also. And last is do the same for M file. Now you people will do and show me in task 4. So first we need to read letter is equal to read table. What is the file name? m.txt. After that, what do we need to do? We need to plot it, right? Plot what? Okay. Now we need to plot what? Letter dot x, comma, letter dot y. Now what do we need? We need axes to be equal. Yes, read table. Pick on, very good. So my task 4, I am doing the same thing for M. Shall I do it? Okay, I have executed unrecognized variable read table. All right. Done. Now see, this is what M looks like. Okay. Done. I have submitted it. Now we'll move to classification. We have half an hour and I want all of us to complete that. Done with this? Yes, no, no, yes. All right. Okay, Zafar, Toshika, yes. Shall I move to next section? Rishabh, okay, we'll wait for you. Okay, Dr. Sharulata, good. Anybody else who has done? There are 61 participants, including me. So you can do same for V text also. Let's do that also. Meanwhile, I will do it for V text. And here is my file. Okay. These are handwritten text data. Okay, Mr. Alok. All right, I'm moving to the next section. So we have understood how to input the tabular data, how to plot the data within the data, and then how to plot it with the correct aspect ratio. So we are going to the next session. This is now pre-processing of the data. So we have already done what? We have already. So this is what is, we have already checked the aspect ratio, right? Now we will try to normalize the data. Okay. Now it is saying the handwritten data measures the pen's position in normalized units 0 to 1. Okay. However, the tablet used to record the data in square. Okay. So this means vertical distance from 1 corresponds to 10 inches. This. Okay. While the same horizontal distance corresponds to 15 inches. To correct this, what we will do? We will adjust the horizontal unit to 0 to 1.5 range instead of 0 to 1 range. Okay. Currently data is like this, 0 to 1. But when it was collected, it was supposed to be 15 inches. So now we have to convert this range from 0 to 1 to 0 to 1.5 to make it correct. Okay. So this is what we are trying to do. We are pre-processing the data. We are standardizing our data. Okay. Let's do it. So what we will do here, see, it is saying we already have M file now. We already have plot. Here we will do the aspect ratio, that normalization thing. Okay. So how do we do this? So in MATLAB, x is equal to x plus 3 means all the values in x will be added with 3. Okay. So now it is saying multiply the values in x variable of the table letter by aspect ratio of 1.5. Then reassign the result back to x so that letter contains the correct data. Now here we have to do. So we will have letter dot x is equal to letter dot x. We have to do what? We have to multiply it with 1.5. Done. See, the values have changed. Now it is starting is 1.1040. Earlier it was 0.736. And now when we have plotted it, this is what is plotted. Right? Now it has changed the value. Right? So this is done. Are you all with me? Have you people done? Now see, the range has changed. If I will show you this, see, now the range has changed. Right? Earlier it was different for n. Now it is starting from 1.1. Earlier it was somewhere here. I hope all of you are with me. Yes. All right, let's finish this. Now we are saying shift time variable to letter of the table letter. So it starts from 0 now. Earlier it was not from 0. So what we need to do? Convert the values into milliseconds. Just pick this. So we are converting seconds to from milliseconds to seconds. So where is time? Time is at letter dot time. So letter dot time minus letter dot time 1, because we have to start it from 0. Earlier it is for starting from 1. This is done. Now we have to convert it into seconds. So letter dot time divided by 1000. And then we are plotting it with X and with Y. Let's do this. I will submit and then we will see it here. Plotting X and Y also. So what are we doing? We are pre-processing our data, right? We have converted time from 1 to starting from 0. And now we have plotted this. This is time for with x-axis, and this is what our time with y-axis is. Now you can see it is starting from 0 instead of 1. Okay. So this is also done. I hope you have done it. We are moving to next section. Now we will extract some features. Okay. Let me show you what we need to do. So now we have to do what? Calculate the new feature. Now we are saying calculate the time taken to write M by extracting the last value and sorting the result in a variable duration. So what was the time taken to write M, to write J, to write V? So we will create a new feature out of these features. The new feature will be the time taken to write the letter M. Of course, it will be more than the time taken to write V or J, right? This is what we did last time, already done. Now we have to take, write the letter M by extracting the last value of time and storing the result in duration. Duration is equal to letter dot time last variable and let me just pick it from here. Simple and after this. So what is the duration? Duration is 0.6080. Let's check what is the duration for V. Point 3080. So time taken to create V is less than time taken to write M. It's done. Which command, Toshika? I'm not sure which command you are saying. So this is what is duration we have checked. Now we'll go to next. So we will say, now it is saying calculate the aspect ratio of the letter by dividing the range of values of letter dot y by range of values of x and assign the result to A ratio. Very simple. So range is equal to maximum of that minus minimum of that, right? So we have to do A ratio is the variable name. We will say max of letter dot y minus min of letter dot y. So this will be my A ratio, right? So which functions are we using? We are using max and minimum. So it will calculate, it will create another feature. This is aspect ratio. We have extracted, right? So aspect ratio is 0.0960. So we have extracted features on. Ratio have the correct value. Ratio has the correct value. Oh, x no. Yes, it has the correct value. So now we have extracted two features out of the existing feature. First, the duration. Next, what is the something has happened. It will be range of values of this by the range values of by dividing letter dot x minus letter dot correct mismatch delimiters. And see the solution. This one we are doing. Let me see what we are doing wrong. Okay, range function itself works like that. I have not read it correctly. Okay. Done. We could have also done it like ratio is equal to max of letter dot y minus min of letter dot y whole divided by, I think it should be correct now, max of letter dot x min of letter dot x. It's correct. Both way we can do. So this is what we have calculated the aspect ratio. So in pre-processing of data, we have done what? We have changed the time from 0 to 1. We have changed the aspect ratio. In extracting features, we have extracted two new features from the existing feature, duration and aspect ratio of the letter. Done? Okay, process data, task 2. This is, okay, the previous one. Okay, we'll go back to that in a moment. Let's finish this. You can check the solution also there in the hint, or you can see the solution. Now see, we have aspect ratio, we have duration for all the characters. Okay, now we have, this is a mat file. How to load a mat file? Using a load function. Okay, so we have loaded mat file, which is of features, aspect ratio, duration and character. Okay, now what we need to plot the extracted features using scatter function with aspect ratio on the horizontal and duration on the vertical. Okay, let me go back to the, okay, tell me which step? Pre-processing. Shall we start from pre-processing? Okay, Toshika, this is for you, pre-processing. So here, this is what we did. So first thing was, our time was starting from 0. We wanted it to start from 1. So we subtracted our time from time at the start, first point, right? And then it said, change it, the time was given in seconds, milliseconds. We want to convert it into seconds. So 1 second has 1000 milliseconds. So what we did, we divided the time feature with 1000. This is what we did in the task 2. Is it okay? Toshika, is it okay? Rishabh? Okay. Now we are going to extract features, task 2. In the task 2, it said, find the, here, calculate the aspect ratio of the letter by dividing the range of values in Y feature and X feature. So you can use range function. Sorry. So range letter dot Y divided by range letter dot X. You can do it like this. Excuse me. Or range is what? Max minus minimum. Or you can also do it like this. Ratio is equal to max of letter dot Y minus min of letter dot Y. So this will give you the range of Y. Okay. Now divide it with the range of X. I did same thing. Max of letter dot X minus min of letter dot X. I did it like this also. So both will work same. You can use directly the range function, or you can create the range by using max minus minimum. Is it done, Rishabh? Okay. Now we are going back to our now we will extract. Now we have this mat file. We will extract features from this. Now we are plotting the extracted features. These are the extracted feature, aspect ratio and duration for each, for different handwritten V's and J's. Okay, this is what the data is created. Now it is saying plot it using scatter. This is what is the scatter plot of aspect ratio versus duration. Okay, so simple plot function was used to plot the lines. Scatter is used to plot the scatter plot. Done. Okay, we'll go to the next. It is saying use GS scatter function, which is used for grouped scatter plot, right? Now we will create the same scatter plot as above, but grouped by the letters. So we will do as per the categories, right? So instead of scatter, we will use G scatter. Feature dot character. We have to tell it is scattered over what. It did not plot. Now it will be with different colors. So this is a plot. Blue is for J, M is for all the values of M, red is for all the values of M, and yellow is for all the values of B. So we have done 2 plots also. Now we will build the model to classify all these J, B, and M. All right, so this is what the classification model is. We'll classify it into 3 categories, right? So which classification model is being used? Whatever is the model, let's suppose KNN or whatever, there are some inbuilt functions like fit, classification, KNN. They are different. I will try to include those in the presentation also so that you can refer. Again, we have loaded the features data. Earlier, we had the data of time, X and Y. Now, from that, we have extracted features, right? Now, this is my processed data. Now, on this data, we will try to fit a model, right? Now, what is my model? Model we are using is K nearest neighbor. K nearest neighbor, how does it work? Let me annotate. K nearest neighbor works like this. It tries to find the distance between each data point and then using Euclidean distance usually. And K is a number. If nearest neighbor, K nearest neighbor, K is 3, it will check the data points distance from 3 neighbors, and out of those 3 neighbors, whichever value is less, it will assign that data point to that particular neighbor. Okay, let's not annotate. Let's start with this. So this is what is the syntax of k nearest neighbor. You put the data and then the value responsive variable. Responsive variable means the label, that attribute name, right? So we have to fit the model of the data stored in features by fitting k and n to know classes which are stored in character attribute. Store the resulting model in k and n model. So variable name is k and n model. We will say fit fit classifier consa, which one? K and n. On which data? What is the data name? Features, right? So data name is features. And what is the label? Character. This character is where? Character is feature dot character. Done. K and N. Okay. Not like this. All right. Now see, this is what we have. We have classification using K and N, predicted classes, predictor's name, the features used, responsive name is this, category predictor, J, M, V, and so on. So we have created a model now, right? So our data is fit on the model. Now what you can do? You can also use the model to classify the observations by calculating the features of the new observations and determine. Right now we have just created a model. Now we will check whether how does it work for the unknown data. Okay, let's see. So we will do prediction. So function name is predict. On what? Use the model name and the new data. So we will use store the predictions in predicted is equal to predict is the function. We are predicting our model name is KNN model and the aspect ratio, two values, right? By using 4 and 1.3. Let me see like this. So it is saying this when the aspect ratio is 4, duration is 1.2, the predicted value will be B. Okay. So this is done. Prediction is also done. We have built the model. We have predicted a value. Now we will know how to handle the outliers. See, what are the outliers? In this category of J, there are some data points of V also. And in the category of M, there are some data points of J also. So we'll try to take care of this also. So now we will verify. By default, when we use KNN, it takes nearest neighbors as 3 or 5. Now we will mention in our model itself how many neighbors to be used. Okay. So in the same this, we will now use n number of neighbors. Number of neighbors is equal to 5. Okay, by default it is 1. Now we have changes to 5, right? Let's see. It is done. And now let's predict this value. Now it is saying it is J. See the difference, right? So I will remove this. Submit. Oh, it was supposed to be here. Yes, it is changed. This is done. Now we will evaluate our model based upon some evaluation methods, whether our model is working well or not. So the same model, the same feature, and there is now test data also. This is our test data. On every data point, we will now check the predictions and then we will do the evaluation, right? Okay. So we are now predicting, but instead of 1, now we have test data. Okay. Now we have to store it in predictions. So these are the predictions for all these data. Done. We have submitted. This is the last task we'll be doing. And prediction. Now it is correct. So today you all will finish this task, right? Now we have to compare with the actual values. See, in the test data, the actual character value is also given, right? And we have our prediction. So we will compare our predictions with these characters, whether it is correct or not, right? So we will say is correct is correct. Comparison will be done like this. Yes. So 1 means correct, 0 means incorrect. Done. So we have used comparison. This. Now we'll check for the accuracy. How can we check for the accuracy? We will simply check the sum and then divide it with the number of elements in the prediction. So there are 2 functions. I will show you. Accuracy is equal to sum function will add some function will add all the ones and number of num_l will give the total number of elements in that. So accuracy is 80%. We can further divide it by 100 so that we can get 80. So we can also check the miscalculation rate. Miscalculation rate means how many predictions were wrong. Accuracy was how many predictions were right, right? How can we do that? We can do it by changing this operator to not equal to. Is class rate is equal to prediction not equal to this. Okay. Incorrect is equal to this. Rate is this. Sum of incorrect. 20%. Done. Now we will check for confusion matrix chart. So we have an inbuilt function called confusion chart. We'll compare predictions with test data dot character. Yes. See, this is what is the confusion matrix. In this, we say it as confusion chart. So there are two classes. These are the predicted classes. So this is actually it was J, and predicted was also J for 4 data points. Actually it was M, and predicted class was also M for 3 data points, but for 1 data point it was predicted as B. Okay, this is how we read the confusion matrix. Actual class was V and predicted class was V for 1 data point. For 1 data point, it was predicted as J. This is what is the confusion matrix. Task 4 is this. Now it is saying check for the misclass rate. Misclass rate will be, we need to check how many were the incorrect predictions. So we used not equal to operator between predictions and test data dot character. And then we checked the rate by taking the sum divided by number of predictions. Okay. Got it? Is there a confusion? Are the correct order? Okay, we have to change it. So this is a very basic 3 data points, very less number of data points were there. And we have completed how we have understood how to build, the model and how to evaluate the model. Now, what you can do is, you will do this. You will create data store, add pre-processing functions yourself. Then you will do this. There will be more data for doing this, and then you will implement classification models all. Okay, this you will do. You will complete this machine learning on RAM course today. Will that be fine? We have done it earlier already. Now the data has changed. Data is for 3 letters, J, K, O, Q, and so on. The same things you will perform one by one. Will that be fine? That is all from my side. If you will have some issues, I think we'll be connecting back tomorrow for deep learning. For deep learning also, we'll do something on this MathWorks academic portal. But before that, complete this certification. Okay. So I'll stop sharing the screen. How do I stop sharing here? That is all from my side. Rishabh, should I show you that again? Wait.
Participant, if you have any question you want to ask, the session is open for discussion. You can ask any question. No question? Dr. Surbhi Jain, you can conclude the session. And also, dear participant, we have shared the feedback form and quiz both in the WhatsApp group. You can submit by today evening.
Then thank you so much.
Surbhi Jain, are you there? I think she is not there. So, ma'am, thank you very much for this nice session. All the content which you deliver here are very informative, knowledgeable. You start from very basic level about what is machine learning, deep learning, and then demonstrate various example, how we can import the file, and then how we can use this tool for prediction. And thank you to all the participants for the today's session. And always feel free to ask any question if you have. The session is always open for the discussion. Tomorrow we will, as ma'am told that we will cover the session related to deep learning. So once again, thank you to all, and thank you very much to join this session. Have a nice day. Now it is time to end the session. Thank you very much.